Hello everyone. In today's lesson, we are going to focus on tuning and troubleshooting EIGRP. We have learned how to configure. Now, how do we adjust EIGRP and troubleshoot problems of EIGRP? This is where you are going to learn about it. Let's focus first on how to tune EIGRP. So to best learn how to tune, you have to do it as the video progresses. I would suggest you create this topology and all of the information, interfaces, network, IP addresses, and so on in Packet Tracer so that you may follow and do this as we go on. Okay, so the bandwidth of the serial links is used in the calculation, so you can change the bandwidth to follow accordingly. By default, serial bandwidth is 1544. So if you notice here, this is 64 and this is 1024. So you can adjust the bandwidth with the bandwidth command. So this is the basic configuration. You put in all of the interfaces and the IP addresses. And for the serial, you can set it to the appropriate bandwidth. Router summarization is one of the most common methods of tuning EIGRP. Route summarization works by grouping multiple networks together and advertising them as one larger network, also called a summarized route. EIGRP can be enabled to perform automatic summarization at classful boundaries. Classful will be referring to class A or B or C. Okay, so it will automatically recognize the subnets as a single class and create only one entry in the routing table for the summary route. So if you look here, there are three different networks here in R1, but when it summarizes and it sends to R2, it sends a summary update, and that is what will come out in the routing table of R2. So routers R1 and R2 are both configured using EIGRP for IP version 4 with automatic summarization. So R1 has 3 subnets in the routing table. These subnets are all considered part of a larger class B network. If you're not sure how to determine class A, class B, class C, please refer back to the subnetting exercise that I've given you previously. For routers to find the best route for each individual subnet, subnet information must be sent. In this example above, automatic summarization should be disabled, so subnet information will be sent. Automatic summarization is disabled by default for EIGRP version 4 beginning Cisco iOS release 15.0 and 12.2. You can use the show IP protocols command to determine if EIGRP automatic summarization is disabled. To enable automatic summarization, use the auto summary command. To disable it, use the no auto summary command. So this is an example of a show IP protocols command on R1, right? It shows you that the automatic summarization is enabled. It also indicates the networks that are summarized and on which interfaces. Notice that R1 summarizes 2 networks in its EIGRP routing table. As you can see, this network summarized 2 components and this one summarized 3. Since the routing tables of R1 and R2 contain subnets of the 172.16.00 network, they will both advertise the summary route of 172.16.0.0/16 to R3. So both of them have the network, so they will summarize it and send it to R3. So in R3, if you use the show IP EIGRP topology all links, you would view all the incoming EIGRP routes. So as you can see here, it verifies that R3 has received the 172.16.00 summary route from both R1 and R2. It is important to note that only one successor has been chosen due to its faster interface bandwidth. You can use show IP route and show IP route EIGRP to see whether or not automatic summarization is enabled. As you can see here, this is before automatic summarization is enabled, and this is after automatic summarization is enabled. The size of the routing table is actually smaller because the route has been summarized. Automatic route summarization can cause problems if the summary address advertises networks which are not available on the advertising router. EIGRP avoids problem caused by summarization by adding a network route for the class pool network route to the routing table. Okay. This network entry routes packets to a null interface. If you see here, it routes it to the null interface. Now, a null interface is a virtual interface that routes to nowhere. You can consider it to be like a black hole. Any packet it gets is dumped. Packets that match a route with a null zero exit interface are discarded. EIGRP for IP version 4 automatically includes a null zero summary route whenever these following conditions exist. 1. Automatic summarization is enabled. 2. There is at least one subnet that was learned via EIGRP. And 3. There are 2 or more network EIGRP router commands. This example here shows you how automatic summarization could also cause a routing loop. If you see here, R2's routing table contains these 3 networks. Okay. R2 then sends a summarized update to R1, 172.16.0.0. R1 receives a packet destined for the address 172.16.4.10. He looks at his routing table and see he has a route for 172.16.0.0 via R2. So he forwards the packet to R2. Okay, he forwards the packet to R2. Now on R2, the packet doesn't match any of the 3 that they have. So then he has a default route to R1. He will then resend the packet to R1 via the default route. So if you see, a routing loop has been caused. EIGRP uses the null interface to prevent these types of routing loops. Okay, so R2 contains the 3 again. R2 also installs a summary route to null zero interface in its routing table. When R2 receives a packet from R1 for 172.16.4.10, it doesn't find any matches here, but it does match this one, so that packet will be sent to the null interface. Hence, the routing loop is prevented. How do we propagate default static route to the other routers? As we have learned before, static routes are not advertised. So in EIGRP, we use the redistribute static command to route this default route to other routers within the topology. So in the routing table of, let's say in this case R1, you would find that there is a default route, the star indicates that, which was learned via EIGRP. This D indicates that. Okay, EX here tells you that this is an external EIGRP route. Okay, or that the static route is outside of the EIGRP routing domain. 170 is the administrative distance for an external EIGRP route. For IP version 6, it is similar. Okay, we have the static route, and then within the router configuration, we type redistribute static. And it will come out in the routing table like this. This is the external route, this is the default route, and where it was learned from. By default, EIGRP uses only up to 50% of the interface bandwidth because it doesn't want to overutilize the link. You can use the command IP bandwidth percent, then EIGRP, the autonomous system, and how much percentage of the bandwidth you want them to use. Regarding hello and hold timers, EIGRP uses a lightweight hello protocol to establish and monitor connections to its neighbor. The hold time tells the router the maximum time the router should wait to receive the next hello before declaring that that neighbor is unreachable. So you can use the different time interval other than the default by using these commands. Okay, IP hello interval, EIGRP 1, this is the autonomous system number, and 50 seconds. So you can adjust that. IP hold time, EIGRP, again, autonomous system number, 150 seconds. So using this command, whether in IP version 4 or IP version 6, you can actually adjust the hold time and the hello timers. As we have learned before, equal cost load balancing is the ability of a router to distribute output traffic using all interfaces that have the same metric for the destination address. Cisco IOS applies load balancing using up to 4 equal cost paths by default, meaning that if your network has more equal cost paths, it only uses 4. The show IP protocols command can be used to verify the number of equal cost paths configured. So here you would see maximum path is 4 by default. When a packet is process switched, load balancing over equal cost path occurs per packet basis. When packets are fast switched, load balancing over equal cost path occurs on a per destination basis. So Cisco Express Forwarding can perform both per packet and per destination load balancing. If you want to change the maximum value, just use the command maximum path and then a value to modify the default for 4 equal cost paths. Load balancing with IP version 6 is the same as IP version 4. Okay, you can see how it goes using show IP version 6 route EIGRP. It is shown here that this router has equal cost route, so load balancing will be done. Apart from equal cost load balancing, EIGRP for IP version 4 and IP version 6 can also balance traffic across multiple routes that have different metrics. This is called unequal cost load balancing. So setting a value using the variance command in router config mode will enable EIGRP to install multiple loop-free routes with unequal cost in a local routing table. A route learned through EIGRP must meet 2 criteria to be installed in the routing table. 1, the route must be loop-free, being either a feasible successor or having a reported distance that is less than the total distance. This would tell the router that the route is loop-free. Another criteria is metric. Metric of the route must be lower than the metric of the best route, which is the successor, multiplied by the variance configured on the router. How do you configure variance? You can configure variance using the variance command. Okay. So for example, if the variance is set to 1, only routes with the same metric as the successor are installed in the local routing table. If the variance is set to 2, any EIGRP learned route with a metric less than 2 times the successor metric will be installed in the local routing table. So it follows the variance that you set. So that is the end of tuning EIGRP, and now we will look into troubleshooting EIGRP. Most of the things in troubleshooting you know already. This is just to highlight what measures or steps you can take to troubleshoot your EIGRP network. So these are the basics command that you can use for troubleshooting. Show EIGRP neighbors, show IP route, show IP protocols. This flowchart provides a systematic approach to troubleshooting EIGRP. EIGRP neighbors must first establish adjacencies with each other before they can exchange routes. Okay? Reasons why they might fail to establish adjacencies could be the interface between the device is down. While you configure the IP address, you forgot the node shutdown. Two routers have mismatched EIGRP autonomous system numbers. Proper interfaces are not enabled for the EIGRP process. This is typically for the IP version 6. An interface is configured as passive when it shouldn't be, or misconfigured K values, incompatible hello and hold interval times, or misconfigured authentication. So it is very important that while you are tuning EIGRP, you know what you are doing and do it correctly. After a neighbor adjacency is established, EIGRP begins the process of exchanging routing information. If two routers are EIGRP neighbors, but there is still a connection issue, these may be the cause. 1. Proper networks are not being advertised on remote routers. An incorrectly configured passive interface or an ACL or access control list is blocking advertisement of remote networks. Automatic summarization is causing inconsistent routing in a discontiguous network. Now, layer 3 connectivity is the network connectivity, right? Layer 3 connectivity must exist between two directly connected routers in order for a neighbor adjacency to form. Of course, if you cannot ping that person, you are not connected to them at layer 3, how are you going to send a router advertisement? So you can use the show IP interface brief command to verify that the status and protocol of connecting interfaces are up. Ping is another way to make sure that there is a connectivity between one router to another. If ping is unsuccessful, use the show CDP neighbor command to verify layer 1 and 2 connections to the neighbor. Layer 2 problems include misconfigured IP addresses, misconfigured subnets, and misconfigured network addressing. This is where your subnetting skills come. You have to be able to understand how subnetting is done and be able to troubleshoot and identify when subnetting is the problem. When troubleshooting an EIGRP network, verify that all routers participating in EIGRP network are configured with the same autonomous system number. Sometimes, whether or not you typed it wrongly or you somehow forgot what is the autonomous system number, this is a simple mistake that can be done. One is EIGRP autonomous system number 1, and then the other router is autonomous system number 11. So this is a common problem. Okay, so you can check using show IP protocols. Verify that all interfaces are participating in the EIGRP network. The network command that is configured under the EIGRP routing process indicates which router interfaces participates in EIGRP. This is why it is important for you to know what you are configuring in the router. Because the router can modify what you write, if you type IP address, they will go and find the network address for you. That doesn't give you an awareness of what is going on. It is always good to know what you are doing so that troubleshooting can be made easier. You can use the show IP EIGRP interfaces to display which interface are enabled for EIGRP. Connected interfaces must be enabled for EIGRP in order to form an adjacency. Another reason that routing tables may not reflect correct routes is due to passive interface. We know the passive interface commands stop both outgoing and incoming routing updates, which prevent routers from becoming neighbors. Sometimes, while doing the passive interface command, we put in wrong interface, and that would result in no communication. So you can use the show IP protocols command to verify whether any interface on a router is configured as passive. Let's look at this example of a missing network statement. Output from the show IP protocols command show that this network is not configured for routing. So output in the bottom part of the figure shows how to solve this problem. Sometimes certain network statements are missing while you are configuring. So show IP protocols command can help you identify if there is network that you did not configure on the router. Automatic summarization is another issue that may create EIGRP routing problems. Inconsistent routing could be caused by automatic summarization. To disable, you can use the no auto summary command. EIGRP for IP version 6 does not support automatic summarization. So that is the end of EIGRP tuning and troubleshooting. Please do the exercise, follow this video again so that you may have a better grasp of what is actually happening and why. Until the next lesson, goodbye.